Hi, welcome back. In today's video, we're going to talk about two things. First of all, we're going to take a look at how you can get the data out of the Kern AI Refinery with the help of our SDK. After that, we're going to build a very simple machine learning model and deploy it to the cloud with the help of a library called Truss. Let's go. If you are using the Kern AI Refinery for your NLP projects, we want to make your workflow as a data scientist as smooth as possible. Our Python SDK offers some great adapters with which you can get the data out of the refinery with just a few lines of code. One benefit of this is that the data you get is already pre-processed into the right format. Today, we will be using the sklearn adapter, which provides you with the correct format to train models with sklearn. There are also other adapters, for example to build chatbots with Rasa NLU, as well as for fine-tuning Hugging Face models. To get started, let's install the SDK via pip. Open up a terminal and write pip install refinery -python -SDK and hit enter. The SDK works with both the local version as well as the hosted version. In this video, I'm going to use the local version of the refinery. Our Python SDK is very easy to use. To get access, import the client from Refinery. Enter your username, your password, as well as your project ID, which you can find in the URL of your project in the Kern AI Refinery app. If you are using the localhost like I am, you need to set the URI to localhost 4455. From refinery.adapter.sklearn, you can get the build_classification_dataset module. In this module, you can put in the client as well as the names of the column you want to extract. You can find the names of these columns in the settings page of the refinery. In this case, I am using the clickbait sample project, which is already provided in the refinery. Please note that the label columns are often marked with double underscores. Last but not least, we can specify the Hugging Face model with which we would like to process the data. In this case, we are going to use the Distilbert base uncased model. Now we have everything we need to create a machine learning model. For the purpose of this video, we are only going to use a simple logistic regression. Keep in mind that with really good data, even simple models can be really powerful. But feel free to build more sophisticated models with all the freed up time you'll soon have by using the refinery and our SDK. To create the model, we first load in the logistic regression module from sklearn. We then instantiate the model and fit it on the data we got from the SDK. The data is already split into a training and a testing set. After that, we predict on the unseen test set and we test how accurate our model is. Simple as that. We now have a ready-to-use machine learning model, which we want to deploy to the cloud. In practice, this can be a real hassle. Luckily, we found a really good solution to make our life much easier. We are going to use a library called Truss, which enables us to pack up our machine learning model and deploy it anywhere we want. To do that, pip install and then import Truss. You can then call truss.nk_truss on our machine learning model to pack it up. The truss is then saved into the directory of your choice. In this video, we got data out of the Kern AI refinery and used this data to build a cool machine learning model. We then packed up that machine learning model with a library called Truss. we could now use this Truss to deploy on any major cloud platform that we want. In the next two videos, I'm going to show you how you can take this Truss and deploy it on a site called Base 10. On Base 10, I'm also going to show you how you can create a really nice user interface to share with your friends and colleagues. I'm also going to show you how you can take the Truss and deploy it on Microsoft's Azure Cloud with the help of container instances. If you like this video, please leave a thumbs up. If you have any questions or comments, please leave your thoughts in the comments down below. Thank you very much for watching. See you in the next video. Cheers!